Hi everyone, welcome to another session of the HBL files. In today's session, we will be solving some problems about projectile motion. Let's begin. For the first problem, a stone is thrown with a velocity of 8 meters per second into the air at an angle of 40 degrees to the horizontal. These are the questions that we will be answering. For the first question, calculate the vertical component of the velocity. Let us first illustrate the given problem. This is the reference level or ground. This is the stone given with its initial velocity at this angle. Let us enlarge the representation for the velocity. Since this velocity was projected at an angle, we can then determine its x and y components. Notice that the vertical component u sub y is opposite the given angle. That means we can use sine theta. Substituting the given values, we then obtain 5.13 meters per second as the vertical component of the velocity. Next, state the value of the vertical component of the velocity when the stone reaches its highest point. Ignore the resistance. Notice that when an object reaches its highest point, or the highest point of its path, that is the point wherein the vertical component of the velocity changes direction. And for that to happen, the vertical component of the velocity must become 0, which means that at this specific position, the object becomes momentarily at rest if we refer to the vertical part of the motion. So again, the vertical component of the velocity at the highest point will be equal to 0. Next, use your answers to A and B to calculate the time the stone takes to reach its highest point. So in A, we have calculated the vertical component of the velocity, particularly the initial velocity. And then in letter B, we have identified that at the maximum position, the vertical component of the velocity is 0. Since we are dealing with vertical motion, we also know that the acceleration will be equal to the acceleration due to gravity. And here we are asked for the time. If you're not quite familiar which equation to use, I suggest you follow these steps. First is to list down the 4 equations of motion. Then, choose which equations contain time. Notice that the first, second, and third equations all contain time. Next is to check whether the other variables given in that equation are all known. Notice that for the second and third equations, they both contain displacement, which is unknown so far. That means we can use the first equation because V, U, and A are all known. Using this equation and manipulating it to solve for time, we then obtain this. Substituting the given values, we get 0.52 seconds for the time. This is the time it takes for the stone to reach its highest point. Next, calculate the horizontal component of the velocity. To do this, we will again refer to our initial representation of the problem. Notice that the horizontal component is adjacent to the given angle, which means we can use cosine theta to solve this. Substituting the given values, we then obtain 6.13 meters per second as the horizontal component of the velocity. Next, use your answers to C and D to find the horizontal distance traveled by the stone as it climbs to its highest point. Now, if we go back to this setup, this will be a rough trace of the trajectory of the particle or of the stone. This will mark the highest point, and we are asked for this horizontal distance. Then in letter C, we have obtained that the time it takes for the stone to reach its highest point will be 0.52 seconds. That is also the same time it takes for the stone to travel this horizontal distance, because traveling this horizontal distance and reaching its highest point happens at the same time. Next, we also know that the horizontal component of the velocity is 6.13 meters per second. That means if we consider the magnitude only, this is the speed, the horizontal speed. Remember that in horizontal part or horizontal component of projectile motion, there is no acceleration, because the only acceleration that acts on the object is along the vertical, which is the acceleration due to gravity. Which means to solve for the horizontal distance, we can then simply use this equation, which is speed is equal to distance over time. Solving for distance, we have this. Notice that I made use of the exact expressions for the horizontal component of the velocity, which is basically the speed, and for the calculation of the time. This is to avoid too much rounding of error in our final answer. This gives us a value of distance to be 3.21 meters. That means this distance traveled by the object as it reaches its highest point is equal to 3.21 meters. Next problem. A stone is thrown horizontally from the top of a vertical cliff and lands 4 seconds later at a distance 12 meters from the base of the cliff. Ignore air resistance. These are the questions. Calculate the horizontal speed of the stone and calculate the height of the cliff. Again, we will make an illustration of the problem. This represents the vertical cliff. This is the base level of the cliff. We have here the stone thrown horizontally with this initial velocity. And then this is the trajectory of the stone. And it takes 4.0 seconds for the stone to travel this path. It lands 12 meters from the base of the cliff. Next, let's write down our given information. For the horizontal direction, these are the things that we know. It takes 4.0 seconds to travel this horizontal distance. Again, remember, there's no acceleration along the horizontal. Next, for the vertical direction, these are the things that we know. Of course, the time, which will be the same. Initial velocity along the vertical is 0. Notice that this initial velocity given to the stone is purely horizontal, which means in the vertical part of the motion or vertical component, it's as if the stone was dropped from rest. So initial velocity along the vertical is 0. And then the acceleration will also be equal to the acceleration due to gravity. So for the first question, calculate the horizontal speed of the stone. Again, don't be confused with this u over here and the u here. Notice that we have already um, separated or clarified the horizontal and vertical information that we know. Again, this u pertains to the vertical or initial vertical velocity. Okay, so going back, what's the horizontal speed of the stone? Since there is no acceleration along the horizontal, we simply use speed is equal to distance over time. And then solving for the speed, we substitute the given values, 12 divided by 4, giving us 3.0 meters per second. And that is the horizontal speed of the stone. Next, calculate the height of the cliff. Calculate this, we will make use of the vertical components or information for the vertical direction motion. Now, calculating the height means it has something to do with S or the displacement. Again, if you're not well versed in choosing which equation to use, let's again do the following steps. First is to check which equations contain the displacement. Notice that equations 2, 3, and 4 all contain S. Next is to check if we know the values for the other variables. Notice that equations 3 and 4 both contain the final velocity. Again, this is the final velocity for the vertical motion. The final velocity is not known as of the moment, which means we can use equation number 2 to solve this problem. Substituting the given values, we will obtain the value for the displacement to be negative 78.5 meters. But since we are only asked for the height of the cliff, we properly write it as height is equal to 78.5 meters. Remember that height is a scalar quantity, which means we must not have any negative sign in its value. Okay, so that's it, guys. That's how we solve those problems. I hope everything's clear. And as always, thank you for learning with me today. See you in the next session of the HBL files.